All right, 23. Find the values of x and y. Okay, it says that DE is parallel to CD. So what I taught y'all to do is when you've identified your parallel line and a transversal, it helps some students to extend it to make it longer so that you can really see the relationships kind of like we learned them. When it looks like what we learned, it's easier to work with. Okay, so what I'm noticing already is that I've got this angle and this angle. Notice I am not paying attention to that other line. BD, I'm not paying attention to him. I'm not using him as a transversal right now. But what I am using is the combination of those two angles, 65 and y. Those angles together are same side interior to 53. We know that if our lines are parallel, same side interior angles are supplementary. So we know all of those angles, 53 plus 65 plus y, should equal 180. So that's how you solve that one. And then to find x is just corresponding. So if I take 53 and then move it up here, it fits perfectly in x's spot. Those are corresponding angles. And we learned that if lines are parallel, then corresponding angles are congruent. In number 12, we're needing to mark a lot of things on our picture. We're marking parallel lines. Check, check. We're marking this angle 110 and this angle 28. So if we want to find the measure of angle 6, oh, we didn't even need any of that. Angle 6 and the 110, those are just a linear pair. Give me another one from this section that you want me to do. Okay, let's look at number 9 then. When we're trying to find the measure of angle 3, what is so beautiful is that we can use, and you don't need to do this every time. I'm just trying to really emphasize these angles here. We can use alternate interior angles. You see that letter? It's like a Z. This is 28, and this one is 28. Alternate interior angles are congruent. So anytime you can find a pair of alternate interior angles, they're the same measure. So I take the 28 and I put 28. Whenever you see a Z like that, this Z right here, you have alternate interior angles, as long as those angles, as long as the lines are parallel. Number 20. On 20 through 22, you want to look at the angles that you're given, 1 and 5, and you really just want to decide what column they go in. What column do 1 and 5 go in? 1 and 5 are corresponding angles. By the corresponding angle theorem, I'm going to write it out because it's that important. By the corresponding angle theorem, we know 1 and 5 are congruent because they don't start with an S. So, since they're congruent, we take 3x plus 7 and we set it equal to 5x minus 3. And I know you can do the math on that, or the algebra on that. That was just the geometry. Okay, never mind. We are going to solve for x. Okay, so we subtract 3x from both sides. We get 7 equals 2x minus 3. We add 3 to both sides. 10 equals 2x. And we are trucking along with our algebra. X is 5. We did one just like 25 in class. Our goal here, I can already tell, that our goal is to find same side interior angles. Let's look at one transversal at a time. One transversal at a time. That's really important. You know that pairs of these angles add up to 180, but you have to find the right pairs. Okay? So we know AB is parallel to CD. The other two are not parallel. So you need to make sure to pick some same side interior angles, but same side interior angles that are created by the parallel lines. So make sure you pick the ones that are created by the parallel lines by bolding or highlighting the parallel lines. So you're going to do y minus 10 plus 100 equals 180. And then you're going to do same side interior angles. 90 plus 3x equals 180. So what I'm doing there is I'm adding up my same side interior angles to equal 180. You should never have an equation that has both x and y in it at the same time.